So in this video, I'm going to do two variations on this particular question where Sam is down below and he tosses some keys up to Pat, who's up above. We want to find out what's the minimum speed that the keys have to be tossed in order for them to get up to the top. Okay, so let's make our sketch. We're going to follow the plan. Alrighty. So we're going to represent the keys as a little box. They're starting down here, and they're going to go all the way up here, and they're going to go a distance of 12 meters. Okay, now down here, we don't know what the speed is, but if they're going to be caught right here with the minimum speed, that means that the keys have gone up and they're just about to go back down, which means that the final speed here, VF, is 0. Okay, 0 right there. Now, we do not know the time of flight. Okay, delta T. We don't know that. Okay, we do know that gravity is minus 9.81. Okay, and I think that's about all we got. Okay, so with our sketch, we're writing down all of the information that we have, putting it right there on our sketch so it helps our brain process what's going on. Okay, we're looking for an initial speed. So now I'm going to take a look at, we've got to do our graphs first before I forget. So we're starting off with some speed up here. We don't know what it is, but we know after a certain time, which we don't know, it's going to go down to 0. Okay, so our velocity curve is going to look like that. And our x is going to end up, okay, at some time t. All right, here we're going to get up from 12. So we're going from 0 to 12. We got to get up there like that. And that's going to be right at the apex, just like that. So my slope right up here at the top, my slope there is going to be 0. Okay. All right. So I'm looking for a velocity. I know distance. I don't know time. I know another velocity. So I'm going to look at my tools in my toolbox, and Bumblebee looks like a winner there. It's got 2 velocities, it's got a distance, and we know the acceleration. So let's do that. We'll give it a go. Now, of course, I've been doing this a long time, and I know this is going to be the correct way to do it. You won't necessarily know that straight out, okay? What I want you to do, though, because your gut feeling is going to be trying to figure out up in your head how this is going to work out, to try and see how it's going to work out. You probably won't be able to do that yet, okay? So pick an equation, work with it, and see what happens, okay? You may not know if it's the right one or not until you get into it, okay? So don't let that worry you. And if you really have no idea which equation to do, pick one at random and just try it. Okay. If that doesn't work, pick a different one. Okay. Don't get too hung up on which equation do I use. Okay. That's not productive for you. Okay. Just grab one and go. If it's not right, you'll figure it out. Okay. So here we go with Bumblebee. Okay. And so I'm going to write it down fresh. Just copy it. 2a delta. I'm going to put y because it's vertical. I'm going to call it a y. I mean, what we call it, x or y or q, it doesn't matter. Okay. And then I've got just a little bit of algebra to do here. All right. So vi squared, that's going to be vf squared minus 2a delta y. We need the square root of everything here. So VI, okay, VF squared minus 2a delta y. All right, so we're going to take the square root. Now I'm ready to plug in some numbers with this thing. Okay, my final is 0 minus 2, and my acceleration is minus 9.81 meters per second squared. And then my delta y is 12 meters. Okay, so let's take a look at what's happening with our units. So we've got seconds squared in the denominator. I've got meters times the meters. So I'm going to end up with meters over seconds, quantity squared. But once I take the square root, it's just going to turn into meters per second on me. So that's going to work out just fine. All right, so when I plug in my numbers into my calculator then, and I've already done this, the answer is 15.34, and we're actually going to call that 15.3 because we want 3 sig figs meters per second. Okay, just like that. All right, now, so we did our sketch, we did our graph, we did our algebra. Okay, now, does the answer make any sense or not? Okay, and again, this is one, like I talked about during class, where hard to know what that means, but it's not crazy, right? It's not a crazy number. It's not like super tiny, and it's not like super huge either. Okay, so we can be like, okay, well, you know, it's a reasonable number, so we'll go with that. All right. Okay, now let's do a variation on this one. Okay, so same scenario, but what we're going to ask is how far up have the keys gone after 1 second? Okay, so I need to make my drawing again here. Okay, all right, we're coming up here. I know that delta y is 12, delta t, we don't know. We do know our initial speed now is 15 point. And I'm going to say 3-4 just so I have an extra digit to work with once I get ready to put it into my calculator. Okay. Anyway, what we're interested in is actually, though, we're actually interested in not when it goes up to 12 meters, but what happens when it's only been going for 1 second? What is the case then? All right. And so then actually we want to say, well, what is delta y at that point? We don't know the final velocity here either. Okay. All right. So now our graphs, what we had before, all right, is we were coming down something like this. All right. We started at some initial, that's our 15.3 number. All right. And then our time here, we went up to 12 before, and that went something like this. But now what we're interested in is just 1 second. Okay, 1 second. So that's how far we would have gone. All right, and this is how fast we would be going. All right, so we're interested in this right here. What's that value for delta y? And I guess we should probably call that a y. Okay. All right. We made our sketch. We got all of our information on the table. It's kind of like dumping out the puzzle pieces before we put it together. Okay, we got our head around what's going on. Now we're ready to do some algebra. Okay, on this one, Bumblebee and Sam, well, I mean, okay, Sam's not going to help us at all because we don't know anything about the time. Well, we know it's 1 second, but then that's not going to tell us about the location. All right, Bumblebee, we don't know the delta x, and we're not interested in the speed. So anyway, Sam's what we want to get to. So let me write that down. Okay, let's get to Sam here. So if I can put my hand there. Whoops. Just getting there. Okay. Oops. I don't know what I'm doing. Okay. Now you can see I just swapped in a t there instead of a delta t. Psh, whatever. Don't let that worry you. Okay. I don't have to do any algebra because we're actually looking for the delta y. How far actually has it gone? So we'll just put our numbers in here. So I got 15.3 meters per second. 1 second plus 1/2 minus 9.81 meters per second squared. 1 second squared. Okay, let's take a quick look at our units. All right, so my seconds there cancel out. So this term is meters. Okay, this is going to become seconds squared, which is going to cancel the denominator there to leave me with meters. Okay, nice. So my units work out just fine for me. And so we're going to get here delta y. And when I put in all of my numbers, what I'm going to get is 10.4. Okay, 10.4, just like that. Okay. So in 1 second, it gets all the way up there to the top. Okay. Well, not to the, doesn't get to the top, but it gets close to the top, doesn't it? 10.4. That's pretty amazing. I wonder how long it takes to get to the top. Let's do that for fun. Okay, now I would use Sam to do this. Okay, so if we start out with Sam, we have this guy right here, and we're looking for our time. So our delta t is going to be our VF minus VI over the acceleration. Okay, and so that's going to leave me with, well, when I get to the top, I mean all the way to the top, 12 meters to the top, then that's 0. Okay, and my initial was 15.3 meters per second over minus 9.81 meters per second squared. Quick look at our units. Okay, I've got meters cancels meters. That cancels one of those and leaves me with seconds. That's good because we're looking for a time there. And that delta t is, what is that delta t? I didn't work that out. I got to pull up my calculator. Give me just a second here. Let's figure it out. Can you beat me? You try it on your calculator. We'll see. 15.3. Whoops. Oh, I stumbled right at the beginning. You might be beating me now. Divided by 9.81. 1.56 seconds. There we go. Okay. So, yeah. So, at 1 second, it went just over 10 meters. It took another half second to go the additional 1.5 meters or so. Okay. So kind of interesting, but that makes sense if you think about it. As it's going slower and slower and slower. Okay, so it's that last half a second or so, it's really slowed down a lot. Okay, so it's barely gonna go. All right. Okay, so there we go. Now, so I'm gonna close this video out. The next video is gonna be a variation on this. Okay, just to kind of show you a few more ideas that we can do.